My name's Ryan, and welcome back to yet another wacky physics video. Today we have this problem, and it starts us off with a 1,000 kilogram rocket that is traveling with a velocity of 200 meters per second to the right. It needs to turn 18 degrees upward to get back to Earth. The rocket can shoot a 200 kilogram capsule straight downward relative to the rocket, and our job is to figure out with what velocity must the capsule be shot out of the rocket to send it back to Earth. And here is a nice little drawing to show the problem and what we need to do, and with that we can get right into the problem. So what do we know and what do we need? Well, we know that the rocket is 1,000 kilograms. We know that it's traveling at a velocity of 200 meters per second to the right. We know that it needs to get to an 18-degree angle in order to reach Earth, and in order to do so it needs to eject a 200 kilogram capsule straight down relative to the rocket. And we need to figure out what speed that capsule needs to be ejected at in order to achieve this angle. Now, the equations we need to consider when solving this problem are these two trigonometry equations. Sine theta is equal to opposite over hypotenuse. Hypotenuse is equal to adjacent over cosine of the angle. These are simple trig functions you can derive, simple trig equations you can derive from SOHCAHTOA. And we'll also need momentum, which is equal to mass times velocity. And we need to keep in mind that momentum is conserved and that the change in momentum in an isolated system is going to be equal to 0. With that, we can get right into the solving process. So, the solving process. In order to solve this problem, I imagined this problem as a triangle, right? Where our desired velocity in order to get home is going to be like this sort of velocity here, this total component velocity, right? And in order to get that, we need to find this y component, because this x component plus this y component will give us this total component, which is going to be 18 degrees horizontal. Right, that's not the right word. Counterclockwise from this x component. I'm sorry, it's 4:30 in the morning. Anyway, so in order to do that, we need to do some trig first. So first, we're going to need to find this hypotenuse component, and in order to do that, I used cosine theta is equal to adjacent over hypotenuse. That's the k of the SOHCAHTOA. I solved for hypotenuse, and then I just plugged in what I knew. I know that adjacent, this guy, is 200 meters per second over cosine of 18. That's our angle. It's going to give us our velocity vector that we want, or hypotenuse. Then I plug this into our adjacent equation, which is sine theta is equal to opposite over hypotenuse. We solve for opposite. I'm sorry, that is not adjacent, that's opposite. We solve for adjacent, and we get this v vector that we found times the sine of 18, which is going to be equal to 64.98. So that means that this rocket, if it's going to be continue to travel 200 meters per second that way, it needs to also travel 64.98 meters towards the Earth. Just straight up relative to the rocket in order for it to attain its 18 degree angle. Now, this is where we start to solve for, I guess, the velocity we need to shoot this 200 kilogram mass. So like I said, in an isolated system, the change in momentum is going to be equal to 0, which is going to be equal to the 1,000 kilograms times the 64.98, which is the desired velocity we want this system to go, minus this 200, which is going to be the mass of the capsule we're ejecting, times this v, which is what we're solving for. Plug in what we know. Oh, I'm sorry, we've already done that. Solve for v. We get 200 v is equal to 1,000 times 64.98. That's supposed to be 9 there. Velocity is going to be equal to 1,000 times 64.8 over 200, which is equal to 324 meters per second. So that means that in order to get this 18 degree angle, we need to shoot that capsule 324 meters per second out of the rocket, which is really fast. And with that, we are done solving this problem. Pretty straightforward, pretty easy. I'm sorry I fumbled a bit. I'm kind of tired. It's not an excuse, but if you liked what you saw, make sure to like, favorite, and subscribe, and I will see you in the next Wacky Physics video. Thank you.